In this video, we're going to discuss what a solution to a differential equation is, what an initial value problem is, and then we're going to discuss what a linear differential equation is, a linear ordinary differential equation, and then we're going to do some practice problems on linear differential equations. So, first things first, what is a solution to a differential equation? Well, a solution to a differential equation is any function we can say it's y equals yt, which makes the differential equation true. Okay? So recall in the last video I said something like this differential equation. I brought this one up, and so any differential equation that satisfies this equation will be a solution to the differential equation. So if I plug in I don't know, yt as something, and then I take the derivative of that and then I add those two together, I should get 3. And if that's true, then that yt, that initial thing that I picked, is a solution to the differential equation. So this is the dE, right? Yt, so whatever you choose, this is a solution provided that it satisfies y prime t plus yt equals 3. Okay? And yeah, that's basically all you need to know for what a solution is. And then we also need to talk about, while we're at it, we need to talk about what a general solution means. So what is a general solution? A general solution is a solution where it includes all the possible solutions, and usually this means this is like plus c, right? So this usually just means all the possible solutions. Typically it means including the random constants that will be a result of the derivative or the integral, depending on how you look at it, right? So yeah, so basically if we find a solution like yt, and if I add a plus c, right, then yt plus c, this will be the general solution. Okay? That's all it is. So whenever it says general solution, 9 times out of 10, you just put a plus c. But yeah, there's some certain conditions that we'll go over for sure. Okay? And then now we have to discuss what an initial value problem is. This is probably the most important concept that we learned today. So an initial value problem, what they'll do is they'll give you some equation, right? They'll give you something like y prime t plus yt equals 3. And then they'll say, okay, y0 equals 3. And so then if you know the solution, so solution is I don't know, we just make something, I don't know, I don't know if you can even solve this, but we'll see. So you said, let's say your sum solution is yt, right? And it's some arbitrary function of x, or sorry, of t. So it's, I don't know, like this is not true, but let's just pretend that it was t squared, right? So it's going to be like t squared plus c, and then you would just plug in the 0 and the 3, right? So they would have 3 and 0, and then so c equals 3. So then that's all it is. This is a way of finding that plus c. Okay? So if you want a formal definition, I could do that. Let's give you a nice definition. So a formal definition of initial value problem is, I should probably write this out. Initial value problem is a differential equation together with one or more conditions that hold at fixed points, right? So you're given a differential equation and you're given one or sometimes even more, right? Depending on whatever the case may be, one or more conditions that hold at fixed points. Okay? All right. And so with that in mind, let's this is basically all you need to know. This is like, I should have put this in the last video, but whatever. So now we start the real bread and butter of this video, which is the I should probably scroll up, the first order linear ordinary differential equation. Okay? So again, it's ordinary because we're going to have only one independent variable. Okay? So the general form of this equation general equation, general form, general form. You're going to get something like a1t y prime t plus a naught t y t is equal to bt. All right? And so note that a1t could be 0 at some points, but cannot be the 0 function, right? So yt cannot just be 0. It cannot be the trivial solution. But you would divide everything by a1t, and then you would get y prime t, a naught t, a1 t, yt is equal to bt, a1 t. And so the form that I want you to know is going to be y prime t plus pt yt is equal to gt. All right? And so what I've just done is a naught over a1 is equal to pt, and b1 or b over a1 is equal to gt. And the reason, hold on, this is bothering me. So yeah, this is what I want you to define as the first order. Okay, here I'm just going to say LDE, linear differential equation. Okay, because I'm lazy. So that's the form of what is a first order linear ordinary differential equation in the green. Okay, and this is in standard form. And the reason why I showed you general form is because some questions are going to give you this a1, like a coefficient here, and then you're going to have to divide it out. So just know that you're going to have to divide this a1 out to make sure that the coefficient of yt is just 1. All right? Okay. So with that out of the way, now let's show you how to get the solution of a linear differential equation. So how to get the solution yt. All right, that's the question. All right, so again, our our equation is y prime t pt yt equals gt. So we need to get what's called an integrating factor, right? This is using the integrating factor method. So I should probably write that down. There's another way of doing this, I think, but I don't know. I like this way. It's more intuitive. Okay, so you get mu t is equal to e to the integral of pt dt, and then that's your mu t, and then you're gonna get your solution is equal to yt 1 over mu t integral mu t gt dt. Let me just check my notes. Gotta double check. Oh yeah, and then just to be kind of foolproof, add a plus c. So when you integrate, when you get the solution to this, like after you've integrated, note that you've already got the plus c. So don't add like another c. Okay, we already have one. That's enough. Yeah, so that's your solution here. Okay. Yeah, and now that we have our solution, this is how you solve it, right? So you're gonna first bring the differential equation into this form right here, right? Where the constant of y prime t is just 1. Excuse me. And then you are going to get an integrating factor, which is going to be done using this. And so when you take the integral of pt, do not add a plus c, because in this equation, in the third equation, we've already got the plus c. So don't worry about that. So, and then once you got mu t, then you plug mu t into this equation right here, into the solution, into part 3. And then that's how you get your solution, yt. Okay? And if you're given an initial value problem, then you're going to have to solve for c. All right. Let's do an example. All right. So, let's go. Oh, it's this way. Haha. Okay. So, question number 1. All right. Find the general solution of the differential equation dy dt plus 2y is equal to 2e t over 3. Okay? And so now I'm trying to confuse you a little bit in 2 different ways. So just before you go off and solve this on your own, just know that it's general solution. And when I say general solution, know that I'm just asking you to give me a value, give me a plus c, basically. Okay? All right? And then you have this thing, dy dt. Think about in the first video what I was showing this. So think about what dy dt means. Okay? So go off, try and solve this on your own, come back. Okay, I've assumed that you've went off on your own and you've solved this, and so now we're going to go off and we're going to try this equation and we're going to show you how to do it. Okay? And then just as a bonus, so that I do more work, and find a solution to solution with y0 equals 2. All right? So let's go off and let's do this. So first step we need to do is we need to let's actually go back to this page, and let's steal this, and then let's make this smaller. All right, so let's go over this. So first thing we need to do is we need to bring it into this form. All right, so y prime t, so dy dt is just y prime t plus 2y, and again y with respect to t, 2e t to the power 3. Okay, so now first thing we got to do, we did that, and now second thing we got to find the integrating factor. So let's find the integrating factor. So mu t equals e integral, and then pt is the coefficient of yt, right? This thing, so that's 2 dt. So then e to the 2t is equivalent to your integrating factor, and my battery's running out, so let's just quickly do this. E to the 2t, there you go, and then yt is 1 over mu t, right? And so mu t again was e to the 2t integral e to the 2t, gt is 2e to the t over 3, right? dt plus c, and then we'll figure out what the hell plus c is, right? Okay, so let's scroll down a little bit. All right, now let's solve this stupid thing. So yt is equal to e to the minus 2t integral, I'm going to bring this 2 outside, e 2 to the t, e t over 3, dt plus c. Okay, so now when you have exponents, and then you have powers, and you have the bases that are the same, right? Both of the bases are e, then you can just do 2t, you can just add them, right? So then that is going to be 6t over 3 plus t over 3 is equal to 7t over 3, like so. So then if I try and solve the integral of 7 over 3t dt, that will yield, or I should be more clear, right? This just came down, and then if we keep working this, so then 2, so then we go here, and then 3 over 7, we solve that integral, 3 over 7, e to the 7 over 3t, because we already have the plus c, we don't need to write another plus c, there you go, and then you get 2e to the minus 2t, 3 to the 7, e to the 7 t, like so, plus c e to the minus 2t. All right, and then 6 over 7 e to the minus 2t plus 7 over 3t plus c e minus 2t. So again, we just added the 2t's, minus 2t plus 7 over 3t, so minus 6t over 3 plus 7 over 3, so then that's just going to be t over 3, right? I should be more clear, 1/3 t, right? So 6 over 7 e 1/3 t c e to the minus, to the power of minus 2t. All right, that's your yt. But remember, I also gave myself an initial condition right here, right? y0, this is your initial value problem, y0 equals 2, right? So now let's solve that. So this, hold on. So this is your general solution. Okay? But now we're going to solve using the initial value problem, right? And what we're going to find now is our particular solution. And I'm sorry, I should have defined what a particular solution is formally, but it seems pretty trivial, right? Because it's just particular, right? It is particular because we have an initial value problem, right? We have a particular solution. We have one solution given some condition, and this condition in this case is y0 equals 2. So 2 equals 6 over 7 e to the power of, that's just 1, right? E to the power of 0, that's just 1. And then again, c e to the power of 0, that's just 1 again. So then 2 minus 6 over 7 equals c. 2 is 7 over 7 minus 6 over 7. So then that's just 1 over 7 is equal to c. So therefore, yt, based on the particular solution, is 6 over 7 e 1/3 t plus 1/7 e to the minus 2t. Okay. So now let's do the next problem. So number 2, solve the initial value problem such that you have 2y prime plus ty equals 2, y0 equals 1. Like always, go ahead, give this a try, and then come back when you've tried it. Okay, let's begin. I'm hoping you've tried it. So first thing we gotta do is we gotta put this equation into standard form, right? And this is not currently in standard form. And we know it's not currently in standard form because y prime's coefficient is not 1, it's 2. So let's divide, right? So let's divide, let me rewrite this. So let me make sure it's more clear, right? So y is always with respect to t, and that's what it looks like. And so now y prime t plus t over 2 yt equals 1. Okay, so then now the next step is to find what the integrating factor is, right? So the integrating factor, let me remind you, is mu t is equivalent to e to the integral pt dt. So then this is e to the t over 2 dt, and this just means it is e to the power of t squared over 4, like that, right? Because when you take the integral, yeah, that's what you end up getting, and that's not very pretty because you can't exactly simplify this when we do yt, when we put it into the big main equation, mu t so if we do the following, we're going to get 1 over, actually let me just t squared over 4, and then this becomes e to the t squared over 4, and gt is 2 dt plus c, right? So that means that we have to take this ugly integral, and let me save you the headache. This we cannot write as some elementary function. This is beyond the scope of this course. So you have to leave it here like so, and basically the bounds of this integral you would have to write, or actually yeah, you would have to write. So we could rewrite the bounds to make it a bit more clear, that we go from 0 to t e to the s squared over 4 to ds. And I'm like, the reason why I'm switching to s is just to make sure that when I bring this e to the minus t squared over 4 in, that I don't accidentally mess it up, that I don't like combine it, just to be more clear. So let's expand this. So e to the minus t squared over 4 t0 2e s squared over 4 ds plus c e to the minus t squared over 4. So then this is the value of yt. But now remember, up here we were given an initial value. We were given a condition. So y0 is equal to 1. So now we gotta put this in. So 1 equals e to the 0, which e to the 0 over 4, right? That's just this whole thing. E to the 0 is 1. And then t is this, right? T is 0. And if t is 0, well, if you think about what an integral is, right? This is some integral. What you always do is integral represents the area under some curve. So you have some distance, right? But if we're going, our lower bound is 0 and our upper bound is 0, then the value of the area underneath that curve must also be 0, because the width is 0, right? So that's 0. And then c e to the 0 again, so then c just equals 1. And so then you can rewrite yt as e to the minus t squared over 4 t0 2e squared over 4 ds c, or just it's going to be e minus t squared over 4. Okay, so this is your answer. This is your particular solution. And then this is your general solution. Okay? Yeah. Okay. And now let's do one more example. So for your last example, solve this. Solve dy dt minus 3y equals 5 minus 2t. Like always, pause the video, go try if you can do this on your own. Okay, let's do this. So first thing we got to do is we got to put this equation into standard form, right? So let's put it into standard form. So yt minus 3y, oh sorry, this is y prime t, yt 5 minus 2t, right? This is in standard form. Now we got to find the integration factor. So that's e to the pt dt, and then pt is the constant. Pt is the constant of the non-derivative, right? So it's just minus 3, right? So minus 3 dt, okay? And then this is e to the minus 3t. And then now we have to plug that whole thing as the solution of 1 over mu t integral mu t gt dt plus c. So then we gotta put this in. So then we do 1 over e to the minus 3t to the minus 3t, and then gt is 5 minus 2t dt plus c. This is your yt. Okay, and then let me scroll down. So then now this is e to the 3t, and then now I'm just gonna expand this big integral out into two different integrals. So then that's 5 e to the minus 3t dt minus 2 t e minus 3t dt, and then this is all in a big bracket plus c, like that. So then now there's a bit of a problem. It's not too big of a problem, but this needs to be done by integration by parts. Okay, and the integral of this, well, we can just say, okay, this is 5 minus 3 e to the minus 3t, right? That's what that comes down to. But as for this guy, we're gonna have to solve this. So let's go ahead and quickly do integration by parts. So recall, integration by parts, for those of you who've forgotten, is u dv uv minus v du. Okay, so our u is something and our dv is something. So let's see, what would we want to take the derivative of? I think t would be good, and e to the minus 3t, and so v, so then 1/3 negative e to the minus 3t du equals dt. So then uv is minus 1/3, oh Jesus, my iPad almost fell, minus 1/3 t e to the minus 3t minus v, which is that junk, 1/3 e to the minus 3t, and then du, which is dt. So then this is minus 1/3 te minus 3t plus, what would this be? Negative 1/9 e to the minus 3t, like that. So that's your integral. So then we know that, which is good. Let's plug this in. Let me scroll down. Okay, so then this, I'm just going to bring this thing over here, right? So e to the 3t minus 5/3 e to the minus 3t, then minus 2, and then in here we take whatever we found here. So minus 1/3 t e to the minus 3t minus 1/9 e to the minus 3t, and that's that, and then plus c, like so. Yeah, and then you gotta simplify, and then basically, hold on, basically that's your yt, and then you would just simplify. But I'm gonna be so lazy right now, I don't even want to simplify. But yeah, so you would just combine this and this term, and then you would bring in the e to the 3t right here, and you would expand that all out. Yeah, and since we're not given a initial value problem, then we don't have to really worry about the c. We could just leave it as a general solution, and that's good enough. Yeah, so that concludes your introduction to linear ordinary differential equations. Like always, if you have any questions, please put them in the comments down below. I would be happy to answer them. See you in the next video. Bye-bye.